Now, talking about weird things, this is an artist rendition of a galaxy having, well, let's call it an episode. It's having a period of time where it's going through some things, let's just say. But what could be causing this? It's actually the black hole down at the very center of the galaxy, undergoing an accretion event, glowing very brightly, and it dumps so much energy around that region that you can actually create a massive galactic wind where it blows out a lot of the gas that's down near that black hole. Another artist rendition of it here. This one also shows a jet. This is kind of closer in where that accretion disk is. So don't get too confused. The bulk of the galaxy is much, much further away. This is that gas and dust spiraling down into the black hole, heating up, getting so hot that it's creating a wind blowing everything away and a narrow jet as well. And you can see this wider component will help contribute to the wind as well. This thing is what's known as a quasar. Quasars were determined, they were originally called quasi-stellar radio objects. They were bright in the radio. Our radio telescopes picked them up as loud sources, and they slewed over our optical telescopes, and it looked like a star was there, kind of quasi-stellar, kind of like a star. Turns out these things are massive, supermassive black holes in the cores of galaxies with material falling into them, generating a ton of energy. Now you might say black holes, I thought they were black, why are they glowing? Well, the black hole shouldn't be depicted as a bright glowing dot down in the center there, perhaps. It's actually the material falling into the black hole gets superheated as it falls in there and runs into other material. It's kind of like falling down the stairs and you're hitting stairs along the way down. You're going to do a lot of damage, you're going to break a lot of things, you're going to glow before you fall into the pit that's the basement that nothing ever returns from. So that's kind of what's going on here. Now, scientists have seen what's called this galactic wind coming off of this object using a variety of techniques, but you can see it in primarily radio waves is the easiest way to see these things. The Alma telescope, using, well, submillimeter waves in radio, is able to see these sorts of things. So deep in the center there, you can see the disk of red, which is the galaxy itself, and the blue is depicting the model showing that wind coming off this galaxy. So you see the narrow disk of gas and dust with the wind blowing out from the center down there. And my dog is dreaming down there, crying out. It's very cute. He thinks he's barking. So here's the Alma images, or the Alma data that prove this. So first on the left, here's where the galaxy is deep down in there. Now it doesn't look much like a galaxy, I know. These are the Alma observations, the radio observations. They've color-coded them for their velocity. Red things are moving away from us, red shifted. Blue things and purple are moving towards us. Green is not moving, well, is not moving relative to the basic galaxy towards or away from us. So this is saying there's rotation. It means that the red side, again, is going away, the blue towards, it has rotation at that spot. Now, if we move over to the right-hand plot that's there, this is showing you how coherent that rotation is, how disturbed it is. And it turns out on the edges, it's rotating pretty continuously. The gas is moving as a whole. And down near the center, it's a little bit more disturbed. There's clouds moving around, there's more disturbance. That's what you'd expect for a black hole down there in the middle, disturbing things. Then on top of it, it's not shown in this, but on top of it, that galactic wind coming off of all of it was seen as a much broader component that was around the entire observations. So the whole picture, you've got a disk of gas and dust and stars deep inside there, a black hole, material falling onto there, and the gas that was formerly forming stars is down inside of there, and it's being blown out by this galactic wind. Now, why is this important? Why am I telling you this story at all? Maybe I should have told you that at the beginning, but you can backtrack, watch it again. What's important about this is we don't really understand why some galaxies stop making stars. In fact, the mass of a black hole is related to the mass of the galaxy sometimes, especially the bulge component of the galaxy. So the fact we're seeing a wind coming off this black hole gives us ideas of how that wind could blow out the gas and shut down the star formation in that galaxy. It's a feedback mechanism that can happen. So just like terrible feedback will ruin a guitarist if you plug it in and the feedback goes into the amp, feedback can ruin the star formation in a galaxy. It blows it all out of the galaxy. So these sorts of studies, seeing this stuff happening, is telling us about how galaxies get their shapes, their forms, and I'm going to tell you more about that after in the second half. I'm going to go into a little more detail on this.